this video, we're going to go over some properties of the normal distributions and how we can use normal distributions to calculate some probabilities. All right, so quick properties of normal distributions. Normal distributions are symmetric about the mean and they're unimodal. So often when we talk about normal distributions, we talk about something known as the bell curve. I don't know if you heard of that before, but the bell curve is simply if this was like let's say this is a timeline of a number line of all my data values as we go from negative infinity to positive infinity. A distribution of my data values, if they look like this, that bell curve where it's unimodal and symmetric. And remember, so just think of this as being kind of like a curve that kind of mimics the height of these histogram bars, all right? If they're unimodal and symmetric, then we say it's a normal distribution, all right? The center of a normal distribution is the mean, whereas the standard deviation determines in how wide the normal distribution can be. So if you'll allow me here, let me come down to the bottom. Let me show you what it does. So let's say we have, once again, all of our x values going from negative infinity to positive infinity. And let me draw a couple of normal curves here. Let's say I have a normal curve. It does something like this. And the tails of these normal curves, they extend forever. Okay, they just get closer and closer to the horizontal axis, but they don't cross. So let's say that's one, and then let's say we have another normal curve. Actually, let me draw that a little better. Let's say we have another normal curve that does something like this. Okay? All right, so what we have here in the red and the green are two separate normal curves. Well, how do we know the difference between them? Well, the center of the distribution, right, just go to the peak, right? Go to the peak, that's the center of your distribution. That's the mean. So as we look at these, since the mean of the red curve is farther left on that number line, that means that the mean of the red curve is smaller. So the mean of the red curve is less than the mean of the green curve because its center, where it lies on that number line, is farther to the left on that number line. The standard deviation measures the width of that curve, right? So imagine like a scrunchie or a rubber band or something. As I tug on that scrunchie and rubber band, it's going to stretch apart, but it's going to become shorter. So the larger my standard deviation, the shorter my distribution becomes, or shorter and wider it becomes. The smaller my distribution, the more tightly packed the data values are, so it becomes skinnier and taller. So the standard deviation of the red curve is going to be greater than the standard deviation of the green curve. If I could ever learn how to spell green. Okay, so I hope that's just a quick little illustration of what the mean and standard deviation do to a normal curve. All right, back to our properties. The area under the normal curve was 1. So it will always be 1, and that's very important. We're going to use that fact whenever we get to calculating probabilities. And then there's this thing called an empirical rule. It's basically just a rule of thumb. It says that if you have a normal distribution, or approximately normal, about 68% of the data is going to lie within one standard deviation. So you go to the center of the mean. If I go one standard deviation to the left, one standard deviation to the right, that swath of area, that swath of data values, it's about 60% of all my data values. If I go 2 standard deviations to the left and right of the mean, I'm going to get about 95% of my data. And if I go 3 standard deviations to the left and right of the mean, I have about 99% of my data. So I have about all my data within 3 standard deviations when the distribution is normal. So that's why if you ever heard the phrase that if you're more than 3 standard deviations away from the mean, you're an outlier, aka a weird value, that's where that came from. All right, but there's all types of normal distributions out there, but a really particular one, the rock star of all the normal distributions, is called the standard normal distribution. And what that is if we have a distribution of z-scores, right? Remember we talked about that in the previous video. If I have a a distribution of z-scores, I have what's known as the standard normal distribution. And it's known as the z-distribution. So whenever you're dealing with the z-distribution, z-scores, your mean will be 0 and your standard deviation will be 1 by default, automatically. All right, let's get into a few examples to see how we can use this information regarding the normal distribution. So first of all, what I have here is, for example, we have a couple of histograms. And we want to indicate if these histograms give us normal distributions or not. All right, let's look at that first histogram here. We'll notice here that if we were to kind of draw a curve right around that histogram there, you notice that it is not unimodal, right? There's not just one peak in this curve that we drew here. For that reason, this is not a normal distribution. Okay, now it is symmetric. It is pretty symmetric, but it is not unimodal. All right, so not a normal distribution. However, the second example here of a histogram, if we were to kind of draw a curve here that follows the heights of those, that's relatively symmetric and it's unimodal. Therefore, yes, this particular histogram is indicative of a normal distribution. So that is a normal distribution. So the first one is not, but the second one is a normal distribution. Okay, moving on. Suppose that we have a data set and it's approximately normal. So we just said that means the histogram is symmetric and unimodal. The mean of this data set is 40 with the standard deviation of 2.5. Draw the normal model using that empirical rule of thumb that 68% of the data is within 1 standard deviation, 95 is within 2 standard deviations, and 99.7 is within 3 standard deviations. Okay, so in order to do that, let's draw this out here. So I have my horizontal axis there. Okay, and what I'm going to do is, since it's a normal distribution, I'm going to draw my normal curve. Here, let's do it in black, my normal curve. All right, it's that bell shape or mound shape distribution. And these tails, remember, they extend infinitely on. So does my number line. So sorry how that's looking. And I like to do this right down the middle. Okay, what value is that? Remember, we say the center of a normal distribution is the mean. The mean of this data set is 40, so that means that value right down the middle, where that peak of that mound is, it's going to be 40. Okay, so 68% of my data lies within 1 standard deviation, and the standard deviation is 2.5. So that means, let's go a different color here. If I go to 40 and I subtract away 2.5, that will give me 1 standard deviation to the left. So if I do 40 minus, let me do a different color. Yeah, 40 minus 2.5, that gives me a 37.5. Okay? Once again, if you need a reminder there, that was 40 minus 2.5. All right, let's draw, let's do a dotted line here. Okay, I'm gonna do the same thing. I'm gonna add 2.5 to 40. So that'll be here, that'll be 42.5. Okay, that dotted line here. So what we are saying is that between those two blue dotted lines, 68% of our data will be between 37.5 and 42.5. That's what it means to be within 1 standard deviation. Now, let's do it for 95%. 95% says you need to go 2 standard deviations to the left and right of the mean. Is that in a different color? Well, either I can say 2.5 times 2, which is 5. I could do 40 minus 5, or I could just simply take another 2.5 away from my 37.5. Whichever way that you look at it, this value right here should be a 35. Okay. And in the same fashion, if I take 42.5, add another standard deviation of 2.5 to it, I get 45. So now between those two green lines, right, I'm going to have 95% of my data between those. All right, and then lastly is 99.7. We just tack on another 2.5 to our last value here. And let's do that in, I guess, this color, blue. So if I come here, if I take 45 plus 2.5, that's 47.5. If I subtract away 2.5 from 35, I get 32.5. And now between these blue lines, I have 99.7% of my data. All right. So that's what they mean whenever they say, draw the normal model. All right, let's move on. So since the total area under the normal curve is 1, we can use the area under the curve's probabilities. All right, so the following examples will show you exactly how to do this, and I'm going to do this using StatCrunch, which is built into our Homeworks platform. If you want to know how to use this in a calculator, feel free to send me an email or stop by my office hours. But let's say we wanted to find the area to the right of a z-score equals negative 1.25. So we want to find the area to the right of a z-score of 1.25, negative 1.25. All right. In stats, it's always helpful to draw a picture, so we'll do exactly that. So we have our normal curve. So when we talk about z-scores, we're talking about normal curves. Let's draw that a little better. Okay. There we go. All right. If you remember, for z-scores, remember what we said about the z distribution? We said the mean, and let me give you guys some symbols here. The mean we use the symbol is mu. That's the symbol that we use a lot. The mean is equal to 0, and the standard deviation, which is the Greek letter sigma, is equal to 1. So if I want to kind of do what we did in the previous example here, just a little bit of it, my mean, and this is our horizontal axis represents all possible z-scores. Right down the middle is where my z-score equals 0 because that is the mean of the z distribution. Now I want to find the area to the right of a negative 1.25. So a negative 1.25 is to the left of my z-score. And let's go ahead and call this a negative 1.25. And I want to find all this area that's all the way to the left of all that area to the left. Okay? So how can we do that? Well, we can use something called z-tables, where mathematicians and statisticians went ahead and calculated all these various areas for us, or we can just use our StatCrunch. So let me show you how to do this in StatCrunch. Okay, if you're in StatCrunch, or excuse me, if you're in your homework system and you want to know how to get to StatCrunch, if you look at the bottom of my screen here, there's a Get More Help button, and then there is a StatCrunch option. So that's how you get to StatCrunch if it's not readily available for you. All right, so how do we get to calculating the area with these normal distributions? Well, what you're going to do is, let me see here. You're going to hit your Stat button. So up at the top, you'll see StatCrunch, Applets, Edit, Data, Stat. We're going to hit Stat, and we're going to select Calculators. And what calculator do we want? We are dealing with the normal distribution. So you're going to select the normal calculator. And it brings up this screen here. All right. And so let me go back to our question at hand here. So we want to find the area to the right of a negative 1.25. Let me give you some notation here. What this is saying is, as I told you before, areas are going to be the same thing for probabilities when we do normal distributions. So big P means probability. We want to find the probability that we select a z-score that is to the right or more than a negative 1.25. That's what we need to calculate. If I want to find an area to the right, just look at where my inequality is pointing. My inequality is pointing to the right. If I wanted to find an area to the left, my inequality would be a less than. And I'll show you the case in a second when you want to go in between two values, but hopefully that makes sense. So now what we do is, if you go down to the bottom of our calculator, they need to know what's the mean of your normal distribution. Well, our mean is 0 because we are dealing with the z distribution, and our standard deviation is 1. So we are good there. However, we need to, let me see if I can pull up my calculator here, my keyboard. And what we need to do here, though, is tell them that, hey, we don't want to find the probability that x is less than or equal to 0, but we said we want to go to the right. So what you do is you tap your inequality, and you can see that you're able to select a greater than or equal to. Let me go back really quickly. You notice how they have a greater than or equal to instead of just a greater than? Let me make this really clear. For normal distributions, okay? And matter of fact, any continuous distribution, if you go on to other stats, greater than and greater than or equal to will be the same thing. Okay? And the same can be true about less than. Less than and less than or equal to, they'll be the same thing. Okay? So don't get caught up on whether it's an equals to or not. Just get caught up on the direction that you want to go. That's the most important bit. All right. So we're going to select a greater than or equal to because we want to go to the right. And then we're going to type in, hopefully, keyboard, a negative 1.25. Okay, then we're going to hit compute, and boom. You'll see first of all the StatCrunch gives us a picture of what we're trying to calculate, and then at the bottom to the right you can see that we get a value of a 0.894. 0.894. So this equals 0.894. So another way of looking at that is saying that 89.4% of z-scores are greater than a negative 1.25. So that's how you interpret that area as being a probability. All right, so all you do is you go to StatCrunch, you put in your mean and your standard deviation, and you select the correct direction that you want to go, whether it's left or right. Okay, moving on, let's see here. What percent of z-scores lie between a negative 0.59 and a 1.05? Let's quickly draw that picture. Once again, right down the middle, that's where z equals 0. That's our mean. And we're going to have a negative 0.59, which may be somewhere over here. And we're going to have a 1.05, which may be somewhere over here. And what we're interested in is that area between those two values. Well, how do we figure that out? We go to StatCrunch. So I'm back in StatCrunch, and notice in the top left of my window here, you see where it says normal calculator, and it says standard in between. So standard is when you want to go to just the left or the right. Between is when you need to go, obviously, between two different values, and that's what we need to do here. So once again, our mean is still 0. Our standard deviation is 1, but now our lower value here, let's do keyboard, is going to be a negative 0.59. And our upper bound here, our upper value is going to be a positive 1.05. Positive 1.05. All right, you're going to put those in compute, and there we go. We get a 57 or 0.576 if we round that to 3 decimal places. 0.576. All right, so let's use our notation here. So the probability that our z-score is between a negative 0.59 and a 1.05, we just said that that equals a 0.576. So there's a 57.6% chance that we get a z-score that's between those two values. All right, just a few more examples here. For example, suppose the heights of high school age males are normally distributed with the mean of 72 inches and a standard deviation of 4.5 inches. Find the probability that a high school male is shorter than 64 inches. Okay. So what we have here is a normal distribution, but it's not the Z distribution. So there's actually two ways we could go about doing this. What we could do is, let's do this. There's two approaches. Approach one says convert the data value to a Z-score. Then find the probability. All right, so check out the last video on how we can calculate Z-scores. Approach two is quicker. Approach two says, don't worry about the Z-score. Just go ahead and type in your information into the StatCrunch. Okay, so approach two says find the probability without calculating the Z-score. And that's what I'm going to do. I'm going to do approach two. I'm going to show you how to do this without using without calculating the Z-score first. Now, it will be a great practice for you to see if you can get the same answer. Both approaches should give you the same answer. So maybe I'll leave that for practice for you guys. I want you to practice this approach. Okay. What I mean by that is step one is find the Z-score. And then step two is find the probability. Okay, but remember, the mean is equal to 0 because you have Z-scores now, and the standard deviation is going to equal 1 when you use that approach, okay? But for this approach, what we're going to do, the second approach, which I'll do now, is we need to find, let's write it out, just use our symbols. We need to find the probability that a high school male is shorter than 64 inches. Now, I'm going to use the letter X instead of Z. Why is that? Because this is not a Z-score, right? We have a normal distribution, but it's not the Z distribution. So I'm going to use X instead. We need to find the probability that a male is shorter than 64 inches. So that means less than 64. Okay? And they tell us that the mean is equal to 72. And the standard deviation is equal to 4.5. All right, so let's use that information. Let's go to StatCrunch. Okay, so I'm going to show you once again how to get to this calculator. You hit your Stat button. Under Calculators, you're going to select Normal. We are going to do the standard option because we're either going to the left or to the right. In fact, we are going to the left. Our mean is, let me double check, our mean is 72. Okay, let's make that look nice. Our mean is 72. Our standard deviation is 4.5. Okay, let's go ahead and hit compute. Oh, I'm sorry. And then we need to change this value, right? We're trying to find the probability that X is less than or equal to 64. Sorry about that. So I know you can't see it, but at the bottom, I need to type in a 64. Okay, so at the bottom, I typed in 64. And that's what you're seeing there. Let me just make it a little better here. We're going to type in 64. Oh, no. It's hard to do this on the iPad. I'm sorry, folks. Let me clear all that out. Type in 64. And there we go. All right, so to 3 decimal places, I know it's really hard. Can I zoom in? There we go. No, it's hard to see, but to 3 decimal places, it's a 0.038. 0.038. So if we go back here, our answer is 0.038. So what's the probability? The probability is that there is a 3.8% chance that a high school male is shorter than 64 inches. Okay, next example. Using the information from the previous example, what is the cutoff for the highest 10% of heights? And also, what's the cutoff for the lowest 20% of heights? So what we've been doing up to this point is that we've been given the z-score, or the value, or the value, and we've been asked to calculate the area, which is the probability. Well, in this particular question, we're going what I like to call backwards. This time we don't know the actual value. In this case, we don't know the height, but we do know the area. So let's take the first question. What is the cutoff for the highest 10% of heights? Okay. All right. So as always, guys, start off with a picture. Okay. So we know that we have a normal distribution. Okay. We are unimodal and symmetric. And we know that from the previous problem, we know that the mean is equal to 72 and the standard deviation is 4.5. So that indicates that we have a normal distribution with a center located at the mean of 72. Okay? And a standard deviation of 4.5. So now they tell us we're trying to find the cutoff for the highest 10% of heights. Because remember, our vertical axis, or excuse me, our horizontal axis represents heights. So we need to find the cutoff for the highest 10% of heights. So what we're basically saying is we want to find the height that is the cutoff that represents the highest 10%. Well, if I'm in the highest 10%, ask yourself, does that mean I am located to the far right of my distribution or to the far left? Well, if I'm the highest, I am in the far right of the distribution. There's only going to be 10% of heights that are higher than whatever this value is. This value at the moment is unknown. But what we do know is the area to the right of this shaded green area here, we know what that is, and that is the 10%. So when they tell you that you're in the top 10% of heights, that means your area to the right is 10%. So my area is 10%, written as a decimal is 0.10. So now our job is to figure out what height is set up so that only 10% of heights are greater than it. Well, just like when it came to calculating probabilities, there's two different approaches we can have with this. We can use the z-score formula, or we can just go ahead and use this, what I call the raw data. And that's what I'm going to do here. And we're going to perform this in StatCrunch. Let me show you how. So in StatCrunch, let's load up our normal calculator. So let me show you again how to get to there. You hit Stat. You click on Calculators. And you go to the normal calculator. Okay? All right. Since we're not going to convert this to z-scores, we're going to use the mean and the standard deviation given to us in the problem. So the mean was 72. And the standard deviation was 4.5. All right? And so remember, we're trying to find the value that has an area to the right of 10%. So that means, hopefully you guys can see this, okay? That means I'm going to change my less than to a greater than because I'm looking at area to the right. And here is the deal. I don't know what to type in that next box. I don't know what my x value is. Instead, I'm going to go over here to where the area of the probability is. And I'm going to change that to 10% because I know already the area to the right is 0.10. And then if I hit compute, guys, it will tell me the height that represents the cutoff for the top 10%. And if you look, I'm going to back out a little bit here. If you look at our normal distribution here, it's showing you that, yeah, I have 10% of my heights are being to the right of, there's our answer, to two decimal places is 77.77. Okay? So that mystery cutoff height is 77.77 inches. Okay? So when you're going backwards, you fill in the area part, the probability part, and you leave the X value alone, and then you hit compute and it will fill it in for you. I hope that makes sense. The next question says, what's the cutoff for the lowest 20%? Okay. It's a similar process, but the picture flips a little bit. And what I mean by that is if we're talking about the lowest 20%, once again, normal distribution, you guys know the picture, normal distribution. We have the same mean, so that's the same center of 72 inches. But now, if I am in the lower 20%, if I want the cutoff for the lower 20%, that now means I'm over on the left side. Let's say somewhere here. Okay? And that means that my area to the left of that I'm shading in here, that is 20%. So here the area to the left is 0.20. And what this means is that now we need to figure out what is this unknown height or X value that has an area to the left of 20%. Well, in order to do that, we're going to go right back to StatCrunch. And here we go. So the mean and the standard deviation are the same, right? We're dealing with the same data set. But now, instead of going to the right, we are going to the left. And now I'm going to leave my X value alone, but I'm going to come over here. I'm going to delete out my area or probability, and I'm going to replace it with 0.20 because I have 20% to the left. All right, if we click compute, that will give us our answer. So let me back out once again. We can see this is a picture where we have the cutoff and the area to the left of it is 20%. And that answer is, to 2 decimal places, 68.21 inches. So X equals 68.21 inches. And once again, guys, I implore you to draw a picture because that makes sense, right? The lower 20% should be to the left of the mean, so we should expect an answer that's less than 72. That's what we got. But in the previous question, when we were to the right of the mean, we should expect an answer greater than 72, and we got 70.77 inches. So anyways, I hope that helps you guys understand how we can use StatCrunch to find probabilities and also how we can go backwards and find the X values or the Z-score whenever we know the area instead or the probability instead. All right, look forward to seeing you guys in the next video.